Hi guys, so welcome back to Clever Knowledge Quest. I am Kelvin Ikechukwu and this is Physics for Early Starters. So this is a concluding part for dimensional analysis. In the other previous videos, we have talked what dimensional analysis is and its importance and how it is being derived. So now we want to use it to check out the correctness of some equations. Remember, that was one of the important factors of dimensional analysis. So we have two equations here. They say check out if the following equation is dimensionally correct. Now V is equal to U plus AT. Now this is an equation for velocity, that is, it has to do with motion and running, where V is your final velocity, V is final velocity, U is initial velocity, A is acceleration, and T is time. So this formula was developed to find a final speed of a vehicle who has an initial velocity and is accelerating with respect to this time. So I want to check if this formula is dimensionally stable and if it is acceptable. Because if it is dimensionally stable, then it simply means it's acceptable and it can stand. But if it is not, then there is an error. So now let's solve this out to check if it is dimensionally stable. Now, what it simply means by being dimensionally stable is that the left-hand side must be equal to the right-hand side. The left-hand side must be equal to the right-hand side. Now, what do we have in our left-hand side? Remember, left hand should be equal to right hand. This is what will give us the proof if it is stable. So now what do we have in our left hand side? We have velocity. And what is velocity? You know that velocity is what? Displacement over time. And what is its dimensional units? You know that displacement is what? L, capital letter L. And we know that time is capital letter T. And they say should be equal to the right hand side. The right hand side we have initial velocity. Initial velocity is still the same thing as velocity, which is L over T plus. Now acceleration is the rate of change of velocity with time. In our previous class, acceleration A is equal to V over T. And what's our velocity? Our velocity is L over T divided by T. And this will become L over T raised to power 2. I did a lot of videos in this in the previous class, so you can watch it there. So this will become plus L over T raised to power 2 times, time is what? Capital letter T1. So from board maths, you know you will have to solve this first. This is 1. So T here 1, T will go into this T, so we are left with 1 T. So you can see that this becomes L over T plus L over T. So we can see that the left hand side we are having L over T, we are also having L over T, and the right hand side we are having L over T. So all of them are having the same dimension, L over T, L over T, L over T. So therefore this equation is correct, and we can use it to solve what we want to solve. So now, back to the second one to check out the second one, if the second one is also correct. Now, the second one says that work is equal to force times mass. Now, therefore, this is an equation that someone is trying to derive. The person is trying to say, wants to calculate the quantity of work which will be generated if a force of certain mass is applied at a given distance. And that person came up with this formula and said, okay, I want to use this formula to check if I will get my answer. And the W here is work. F is force. And M is mass. Now, what is work? Work is simply force times distance. And what is force? Force is mass times acceleration. And we know our mass. Mass itself is a fundamental quantity. So now, to analyze this further, we look at force. We know that force is what? Mass times acceleration, and force is here already. So we want to express this in dimensional analysis. So now, force itself is mass times acceleration. Mass is capital letter M. And acceleration, let me write it down here. Capital letter M. And acceleration itself, we have already seen what acceleration is from our previous class. We said that acceleration is simply L over T squared. So therefore, force is mass times L over T squared times, now distance is also length, times L. So this makes us to have L times L is L squared. So we have M dot L squared over T squared. So this is what work is in dimensional analysis. Now, what is force in dimensional analysis? Let me write it fully here now. Force is mass times acceleration. What is our mass? Capital letter M. Now, what is acceleration? Times L over T squared. So therefore, force is M L over T squared. Now, the formula they gave us, M is mass, and they say work is equal to force times mass. Remember that left-hand side should be equal to right-hand side. So now let's compare and check. What is our left-hand side? Our left-hand side is M L squared over T squared. And they say it should be equal to the right-hand side. The right-hand side is force times mass. So what's our force? We have this force to be ML over T squared times, what's mass? Mass is capital letter M. So now when we multiply this out, we are left with M times M will give us, this will be equal to M squared L over T squared. So in final, we have our left-hand side, ML squared over T squared is equal to M squared L over T squared. So is these two things the same? Here we have M, but here we are having M squared. Here we have L squared, but we are having L. So we can see that they are not dimensionally the same. So therefore, this formula is not correct. So therefore, there should be a unit that needs to be added for this formula to be stable. Please, somebody should do this. Work is equal to force times distance, and then see if you will get the correct answer. So this is this here. I believe you must have mastered dimensional analysis now, and anytime you see any challenge related to it, you'll be able to answer it without not finding any form of difficulty. Thanks for staying, and see you in the next video. Bye for now.